and did, just broke the camera. It's time for a real stand, maybe. So here's fair dice, right? Nobody had these because I'm a bastard. So what I did was I set up a spreadsheet to help me create goofy dice. And there's a point to this. There's a point to this. It'll probably carry us into Thursday, but that's okay. Here, if you guys had blue dice, your distribution should look like this. If you have blue dice, huh? You guys get an average of 8.1666666 with a standard deviation of about 2.65. And if you make the actual distribution into a histogram, it looks like this.
It's SS.
I'm calling it, hey, Anna, thank you for that, Anna. I'm calling it sigma, and you know why I'm calling it sigma and not S? This is a really good point, and actually, Aaron, you brought this up too. I heard Anna say it's SX, not little sigma X. I'm actually calling this sigma and mu. How come? It's a little bit fictitious, but what are you holding in your hand? Say it again. The dice, which are the entire population. You're holding every outcome in your hands. Does this happen in the world of statistics very often? No, not at all. But right now, we started this knowing there were 36 outcomes. So I went ahead and called it mu and sigma because it technically is the population, if that's okay. Yeah.
On the list, is
yes.
The standard deviation of the sigma x or the big S? Sigma x?
Yes, because it's the population. So this is the blue population. I called it skewed left because it's leaning to the right. It's got more. It's heavier on that side than the normal distribution was, which looked. I shouldn't say normal. Than the fair dice distribution was, which was symmetric in the middle. So that's what. Now not everybody had blue. Some of you guys had yellow. This is skewed the other way. So where are my yellow dice? A couple of those floating around. Yes, we got some yellow dice floating around. Your distribution looked like this. You guys had an average of 4.5 with a plus or minus of 2.22-ish. Rounded off, ish. That's what your graph looked like. And I just happened to see Lydia's. It looked just like this. Got his straight little wandering tail down here. Very, very good. Very, very good. Okay? Green. I call this the flipping you the bird distribution. I was trying to build one. that was shaped like a U. So I was trying to build one that went like this. Why did I fail? So I was trying to do this. I was trying to have a spike on 2, and I was trying to have a spike on 12, and it had to kind of tilt down and then flatten out and then rise back up again. Tell me why I failed from the start. It took me about 5 minutes to figure out why I could stop looking for that. Michaela, what are you thinking? Why? Well, yes, although it's higher. If you look at it here, the probability of getting a 2 here is 4 in 36, which technically speaking is 4 times more likely than it was back here on the fair distribution, yes? So it's still low by comparison. But that's my next question is, why is it low by comparison with the 7, Lydia?
Well, to get that a lot of 12s, you have to have 2 6s, and if you have 2 6s and 2 1s, then you have 7.
In order to have a lot of 2s, I have to have a lot of 1s on both dice. 1's on this die and 1 on this die. In order to have 6s, to get 12s, I have to have 6s on this die and 6s on that die. Well, the problem with that, friends, if I've got 6s and 1s on both dice, what else do I have a lot of? 7s. By definition, I have to have that. So I gave up trying to get the U, and I settled for the perfectly symmetric flipping you the bird distribution, which is kind of a fun one. No 3s and no 11s, just like you guys said. So get a gap there, but it's perfectly symmetric. Fun. Average of 7, much wider standard deviation. Why? Because it's spread out a lot more. It's spread out a lot more. I love that distribution. Orange, one of my favorites. My orange dice. You guys had 2 modes. Yeah, you guys had 2 goofy modes because you had all those 3s and 4s on that one die. There was 5 3s and a 4 on the one die, which drove up these results right here, which was super fun. Super, super fun. So that's orange. Notice how they all have the same average, or close to the same average, except for the 4.5. And the standard deviation keeps changing. And then last but not least, you don't have to write these down. You'll have these on the board. I mean, I'll have this PowerPoint for you. And this was the red dice. If you guys had the red dice, these actually look kind of like the normal distribution, or the usual fair dice distribution, except it's all compressed into the right side because you guys had too many large numbers. I don't think there were any 1s or 2s or even.
Yeah.
Maybe there was a 3, potentially. But so that's what the distributions look like. Now here's, maybe I have to wait this minute just for next time. Here's the question I have for you. And we'll continue this in class on, do we have time now? Yeah, let's try it now, because I'll get us out earlier on Thursday. Let's try it now. Is that smart? Is that smart to do? No, that's not smart. Here's the deal. I just handed you dice, and you looked at them. You looked at them, and you looked at every single side on those dice. Yes, every single side of those dice. That's like saying that you're able to observe your entire population. That's why I was calling those things mu and sigma. Yeah, mu and sigma, mu and sigma. So there's a problem with that, and the problem with that obviously is that you can never actually do that in a sample. A sample is not the population, it's a piece of the population, yes? But the thing is that you're still interested in the population. You want to know something about the population, whether it's, will the ADHD medicine work? Let's find out. Whether it's, will the cholesterol medicine work? Let's find out. Will that PT therapy work? When my PT doctor grabs my arm and shakes it like this, is that actually helping me heal my rotator cuff? Or is it just placebo? So you set up these studies, but in order to know if it works in the population, you'd have to actually survey or measure every single member of the population. Well, that's ridiculous, isn't it? Because you can't do that. It's impossible to actually measure the entire population. So what do? You take a sample. So here, we just make it up. Good. That's what CNN does. Careful. So what we're going to do, grab your dice right now, friends. We're going to kick out here early today. We'll start this on Thursday. It makes more sense, I think. Roll your dice. Roll your dice. What did you get? 7, 4, snake, leg eyes, snake eyes, 11. Roll them again. What'd you get that time? 9. 7, 6, 22. Average your 2 results that you got the first time and this time. 22? How dare you? It's me. It's being that guy. So roll them again. Make a note of what you got in your mind. Roll them again. Roll them again. Roll them again. Roll them again. What are you doing each time you're going to roll? Statistically, you're going to make a note of what you rolled, and then you're going to take all of what you rolled and do what with it? You're going to average your results, and that average hopefully will tell you something about your population. The question is, what does it tell you, and how off is it from your population? That's what we can't answer in 10 minutes. I do have an in-class quiz for us to do. However, let's not do it, because we can't do it in 10 minutes. Let's hold this for next class and do it together then. Yes? I think that makes a lot more sense. Yeah. So here's what I want to do. I want to be able to get to these numbers that you guys got to right here. I want to be able to get to those without having to fictitiously know the population. In other words, from a sample, can we get those? And the answer is a surprising yes, and pretty damn accurately. Okay? But not till next time. Let's do this. Make sure you remember what dice you had. Write down the color of the dice you had. And then bring them back up here. Drop them back into the box. And we'll make sure you get those dice back on Thursday. And the experiment will take us most of the class on Thursday. So we'll just do it then. Okay? Hey, Brad, what's this? That's interesting. Scale 2. Let's make it 1. Because that way, that was a little better, doesn't it? And then we can even knock that down. Yeah, I'm much happier with that. Let's fix that. Let's make the Y min 0 instead of 1. There you go. There's an example, because it was cutting off that first line. Cool. You got it? You got it? And you are? Hi! I kind of figured, because I'm like, hey, I don't know that person. I guarantee it's only our line mates. Of course you may. Yes, there's 3 of you. I haven't seen you guys since the first one class. It's very good. You get class quiz on Thursday, it's even better. Alright, so there's links and you. Links and you. I'm giving you a whole bunch. You don't need them all right now, but in case you take other classes, you've got them. And it is confusing. You can be done, but it's good. You got it, great. Good seeing you again. What's up, kids? They're crushing. Anna, what's up?
I know you can't give me the answer.
I can't.
But can you kind of
yes.
see if I'm on the right track?
So what's bothering you?
Well, okay, this number just seems really super high.
But it is, because if that's only 6%,
I know.
this has to be everything else.
Because Linda.
Think about why. It's the chance you have, I know it seems, you gotta remember, I had my disease for this. I didn't know I had a test. Now the trick with here is the test is positive. My response is this: if this is what your test says, if you only have a 6% chance of having your test positive, call that a negative test result. Because there's a 94% chance you don't have it, make that the negative test result. I don't have an answer for this. All I know is most folks don't understand those results, and the fact that you were surprised by it. Hold on. Hi. Let's fix it. Let's fix it right now. Same thing happened with Rob. So it's easy fix. What's he just? I'm done. They're all back. Nope, I overordered everything. So I didn't put them on twice. Got it. What's up, Aaron?
I just overheard about
Oh, about the Lyme disease thing.
that. I thought it was
The four of us. No, it's, well, the test is, I think, labeled.
a false positive, 90%.
Yes. If you test positive, it's wrong. It's like crazy. It's completely insane. How the negative test result came out? Do you remember how the negative test result came out? I think it was actually pretty. Yeah, so the test sucks. What they should do is just relabel. Like, when it says positive, call it negative, because it looks like negative. That's what blows my mind about these tests. If those are off the chart, just relabel the tests. Right? Why aren't they chronic?